All right, we are going to pick up where we left off with multiplying binomials. Multiplying polynomials. In this case, we're going to multiply binomials. Some of you may have heard of the FOIL method. I tend not to teach it because it's only specific to multiplying binomials, and students tend to forget what the F, the O, the I, and the L stand for. And I think that's kind of a teacher's responsibility to make sure that you understand that this is just abbreviations to help you remember. It's actually first, outer, inner, last. But it only works for binomials, and I prefer a method that will work for monomials, trinomials, something with 4 terms, etc. So this is just, I generally just don't even teach the FOIL method. If you want to use the FOIL method for binomials, that's perfectly fine. I just need to make sure that you can multiply these two together. So if you want to use the box method, that's great. If you want to multiply vertically, that's fine too. If you want to use the FOIL method, perfectly fine. So we multiply the x times the x times -2, -6 times x, and -2 times -2. We're going to combine like terms. The nice thing about the box method is that our like terms usually, depends on the original binomials, but they usually end up on the diagonal. So we have a -2 plus a -6 gives me -8x. Remember, when you're adding, you do not change the exponent, okay? So when we add a -2x and a -6x, it still stays x, just as a reminder. All right, so now we have 5x minus 6 and a 2y plus 3. And we're going to multiply 10 times x times y, -12y, 15x, and -18. All right, so normally these are like terms, so we would be able to combine them, but in this case, they're not because one's an x and one's a y. So it doesn't matter which one we put first or second. Although if it doesn't matter, we usually put the x first and then the y. Doesn't matter. Okay. And guys, this is going to be just an awful lot of binomials being multiplied together. So if you feel like you have this down, there we go. You can skip ahead. Perfectly honest, I'm not sure what the end of this section is, so you might want to skip to the end and make sure you catch the last example or two. But it's just right now just going to be a lot of binomials. For some reason, they decided to do lots and lots and lots and lots of examples of multiplying binomials together. So these will combine. They're both x, y. So we have 14xy and this you're going to need. So if you skipped, make sure you come back to this. Yeah, guys, if you skip to this one, you need to come back to this one, and you need to come back to this one. These you need to know how to do. So, did I even end up skipping any? No, I'm sorry. I was hoping that we could skip, but we can't. So, notice we have 3 things together, and I know you guys want to distribute this 3x cubed, but don't do it yet. Don't do it yet. Don't do it yet. You're going to end up with the wrong answer. because you're going to distribute incorrectly. So what I want you to do is multiply the binomials together first. Once you've multiplied the binomials together, then you are going to distribute your 3x cubed. So off to the side, we're going to multiply our x minus 2 and our 2x plus 1. So 2x squared minus 4x, x and negative 2 combine like terms. 2x squared, we add our x's. Okay, only after we've multiplied the binomials together can we distribute the 3x cubed. So multiply times the first term. Remember, you add the exponents. Negative 9, add the exponents. Here's what students do incorrectly. What they do incorrectly, if they try to distribute first, they multiply times the first one, and then they multiply times the second one. Basically, what you end up doing is multiplying the 3x cubed twice, which is incorrect. So, all right. Let's suppose we have x plus 2 times x plus 2 times x plus 2. Do not apply this exponent to each item inside. The answer is not x cubed plus 8. I wish it were that easy. It isn't. The reason why we can't do that is because of this addition. Remember when we were talking about exponents, if this were multiplication, we could apply that exponent to the x and the 2. But it's addition. Different rules apply. So when we have this, what we're going to end up having to do is multiply two of the binomials together, get an answer, and multiply by this last binomial, x plus 2. Okay, so we've got to multiply this together first. X plus 2, x plus 2. Which gives me x squared plus 4x plus 4. Only after we've multiplied the two binomials together do we multiply by that third binomial. I'm going to use the box. So here's my x plus 2, x squared, 4x, and 4. So x times x squared is x cubed. 4x squared, x times 4, 2 times x squared, 8x and 8, and then combine like terms. X cubed, 6x squared, 12x plus 8. Notice, remember how I said the answer is not x cubed plus 8? It isn't. It's not x cubed plus 8. It's x cubed plus 6x squared plus 12x plus 8. All right. Find a polynomial that represents the area of the shaded region. Okay, so we're looking for the area of this. Okay. I call this a donut problem because this is a giant hole in the middle of this outside rectangle. And the way we find the area of just the donut, it's a rectangular donut, the way we find the area of the donut is we subtract off the area of this inside rectangle. It's like we're cutting a piece out of the middle. So we need the area of the larger rectangle, and we need the area of the smaller rectangle. And then what we're going to do is we are going to subtract. We're going to take the larger and subtract the smaller, and that will give me the area of the shaded region. So the area of the larger is going to be our 3x times our 2x plus 1. The area of the smaller is going to be 2x times x minus 3. So when we distribute this, we end up with 6x squared plus 3x. And we need to subtract, I'm going to do it vertically just for room wise. We're going to subtract our 2x squared minus 6x. Okay, now remember, when we subtract, what we do is we distribute the negative. Okay, in other words, we change the signs and add. Change the signs and add. So I have 4x squared plus 9x will be the final answer. All right, and that is the last example.